A real data scientist, the high-end data scientists are mostly PhDs. They often come out of physics, out of statistics. They have to have computer science background, they have to have a math background, they have to know about databases and statistics and probability and all that stuff. However, if you're coming into a data science team, I think that the first skills you need is you need to know how to program, at least have some computational thinking. So you've had to have taken a programming course. You need to know some algebra, at least up to analytics geometry, and hopefully some calculus. Some basic probability, some basic statistics. I mean, you really have to understand statistical inference and different statistical distributions, and database. I mean, one of the easiest places to start is relational databases, which stores lots and lots of our data. So people can first walk before they can run by at least understanding about computers and databases and how we store things. And if you understand relational databases, nowadays you can still, just with that understanding, use big data clusters as if they were just a big relational database. You don't have to really understand the whole MapReduce programming model. But then, as you go further up in the field, then you have to know a lot of computer science theory and statistics. It's really, and probability. It's really the intersection of them that the high-end data scientists, the PhD data scientists, work with. I do a lot of self-learning. I think everybody these days, I mean, I learned about Hadoop all by myself. I read some articles, I watched some videos, I thought, I played. Although I'm a builder, I'm a tinkerer. So when I really if I want to figure out how to do something, I build it. I mean, my first HPC cluster, I'd heard about this term, a Beowulf cluster. And again, I went, what the hell's that? So I looked it up and said, oh, that's just a bunch of computers hooked together with a TCP/IP network. That's pretty easy. So we got a grant from Citibank, and we built a five thing cluster. And I said, oh, that's HPC. So I had one of the first HPC clusters at the university. It was tiny, but a lot of our researchers loved it because they could run stuff 40 and 50 times faster. So I think one of the ways you learn things is you do them. You have to do them. And these online learning platforms, especially now that we have things like IPython and Jupyter Notebooks and I guess Zeppelin, means that you can actually go in and take some of these courses and you can do things right then. And you can see them and feel them and play with them. And at that point, you start to get your head around what is actually happening. Motivation is the key problem in all of these, is how to keep people motivated and how, and I think the badge system that the Big Data University has is one of the ways, is how do you get people to keep going through? But if they want to, they can. Right? It's up to the individual too. So they have to understand what the goal is. The place it can't sit is probably under the CIO, the Chief Information Officer. CIOs, current Chief Information Officers in many companies, got there from an accounting background or a finance background. They're clueless. Sorry, but I mean, they really, it has to come out of the research side, right? So you'll find data scientists primarily in companies that have some research agenda, pharmaceuticals, finance, all of any technology company. If you look at, we can't keep some of our PhD data scientists in our program. They're now at Facebook, they're at LinkedIn, they're at Uber, they're at Lyft, because the demand out there for the PhD level data scientists is just unbelievable. They make large amounts of money and they're playing with problems that are really, really neat. Like, how do you schedule the Uber cars? Right? And you have enormous amounts of data.